Welcome to the BKR chemistry classes. Today we are going to see problems related to specific rotation and enantiomeric excess. First, what is specific rotation? Specific rotation alpha is equal to theta by c into L, where theta is the angle of rotation, c is the concentration, L is the path length of the cell. Now, what is the relationship between percentage enantiomeric excess and specific rotation? So percentage enantiomeric excess is equal to specific rotation of sample divided by specific rotation of pure compound or pure enantiomer multiplied by 100. So this is the formula for calculating the percentage of enantiomeric excess. So based on this formula, we can also find the specific rotation of sample or specific rotation of pure compound. So either of them can be found. Now, what is this percentage enantiomeric excess? So if I say I have 10 percentage of enantiomeric excess of R, what does it mean? This means that I have 10 percentage of pure R and 90 percentage of racemic compound. So in this racemic compound, I have 45 percentage of R and 45 percentage of S. So what is the percentage of R? Percentage of R is 10 plus this 45, so it becomes 55 percentage, and percentage of S is 45 percentage. So in order to calculate the enantiomeric excess, just subtract the percentage of R and S, you will get the enantiomeric excess. Okay. So in this particular problem, they have given 25 percentage of S enantiomer. 25 percentage of S enantiomer. That shows I have 75 percentage of R enantiomer. How to get the enantiomeric excess? Just subtract them. I'll be getting 50 percentage. So I have 50 percentage of pure R. How? Because from this 75 percentage of R, 25 percentage of R and the 25 percentage of S. We know that racemic compound is equal percentage. So it's equimolar mixture of the enantiomers. So I'll be having 50 percentage of the racemic compound, which has 25 percentage of R and 25 percentage of S. So balance 50 percentage is pure. Okay. Now let us solve the problem. Now substitute the same into the problem. So you have 50 percentage of enantiomeric excess. The specific rotation of sample is not known. The specific rotation of pure compound is 48 multiplied by 100. So x is equal to 50 into 48 by 100, which is 2400 by 100. So x is equal to 24. So the answer is 24. A very recent JAM problem asked in 2022 talks about specific rotation of optically pure R 1-phenyl ethylamine is 40 plus 40. And the synthetic sample of the same is shown to contain 4:1 mixture of S and R enantiomers. And what they're asking is they're asking the specific rotation of the neat sample. So we know the formula percentage enantiomeric excess is equal to specific rotation of sample divided by specific rotation of pure enantiomer. So here the specific rotation of pure enantiomer is given, which is plus 40, and they have given 4:1 mixture of S and R. So in 100 percentage, 4:1 means I have 80 percentage of S and 20 percentage of R. So what is the percentage enantiomeric excess? 80% S minus 20 percentage of R. That comes around 60 percentage of S enantiomer. That is, I have 60 percentage of pure form of S and Remaining 40 percentage is racemic compound. Among the 40, I have 20 percentage S, 20 percentage R. So now add on this 60 plus 20. How much it comes? It comes 80 percentage of S. So 80% S, 20 percentage of R. Okay. Now substitute the same in the formula. So percentage enantiomeric excess is 60. Specific rotation of sample I don't know. Specific rotation of pure enantiomer is 40 multiplied by 100. So x will be equal to 24. But look carefully, the R enantiomer has got the plus 40. So R enantiomer has plus 40 rotation. It is dextrorotatory in nature. Therefore S enantiomer will be levorotatory in nature. So minus 40. And here the sample, the percentage enantiomeric excess is 60 percentage of S enantiomer. So we have excess of S enantiomer. So obviously the rotation of the sample should be levorotatory in nature. The previous jam problem which we have seen in this video had 25 percentage of S enantiomer. So we had 75 percentage of R enantiomer and 50 percentage of enantiomeric excess of R enantiomer, and R was given plus. So obviously the product should contain dextrorotatory nature of the sample. But in this particular problem, you have 60 percentage of S enantiomer in excess, and S enantiomer is levorotatory in nature. Therefore, the product should be also levorotatory in nature. Therefore, the answer should be minus 24.